In a sense, it's inaccurate to say that this is the conclusion of diagramming argument, since we'll be talking about it, a lot more throughout the semester, especially the next few weeks. But it is sort of the conclusion of this sort of introductory pass at it. And in this lecture, I just want to say a few things about a few more complicating factors. We've looked at dependent and independent support, some really simple stuff. This stuff can kind of like stack on top of each other to become a bit more complicated. There are also a few other ways that arguments can be more complicated. The first of these is that an argument can have multiple conclusions. So far we've looked at arguments that have one conclusion, but it's entirely possible for one argument to have several conclusions. So here's a simple example. Global warming will continue to get worse for at least the next 30 years, so sea levels will rise and summer heat waves will get worse. So you have two sentences here, global warming will continue to get worse for at least the next 30 years. That's your premise. And it might, you might think, well, we have one sentence here at the end. That one sentence is our conclusion, right? But think about this earlier idea of propositions, right? A proposition expresses a complete thought. It can be true or false. There's one sentence here, but you can actually break this into two propositions. Sea levels will rise, summer heat waves will get worse. These two propositions are really independent of each other. They don't really make reference to each other in any way. You can break the sentence apart. You're not going to really change the meaning. So, global warming will continue to get worse for at least the next 30 years. So the oceans will continue to rise. So summer heat waves will continue to get worse, right? If you had to diagram it, diagram looks like this. One premise leads to two conclusions. An even more important way that arguments can be a bit more complicated, and one that'll surface a lot, is in sub-arguments. So what does a sub-argument mean? Well, sometimes premises will support or be used to prove a conclusion, and that conclusion will itself be a premise in a larger argument. Let me give you guys an example. Forcing people to work without their consent is always wrong. We must work to pay taxes. We have no choice about whether to pay taxes. So by making people pay taxes, the government forces them to work without their consent. It is wrong for the government to make people pay taxes. Now the thing to notice about this argument is if you look at it, 1 and 4 are what get you the conclusion, right? It's wrong to make people work without their consent. Making people pay taxes makes them work without their consent. 1 and 4 get you 5, right? What are 2 and 3 doing here? Well, 2 and 3 are supporting 4. They're supposed to prove premise 4. So, sub-argument and conclusion. 2 and 3 are premises in a sub-argument. 4 is the conclusion of that sub-argument, right? 1 works with 4 to get you this final conclusion 5, but 2 and 3 are supposed to support 4. That's all a sub-argument is. When you have an argument that proves a conclusion that is itself used in a larger argument. Now, but notice, because you have this sub-argument, the structure gets a lot more complex, right? A little harder to diagram as well. 1 doesn't go at the top of our diagram as it does in our argument. 2 and 3 actually go at the top. Dependent support for 4. 4 with 1 is dependent support for 5, right? So Lavin already talks about levels of argument. You can see this one has 2 levels. The ones we've looked at previously have all just had 1, right? One more thing that makes all this even more complicated is that arguments can combine different kinds of support. And how this happens is a sub-argument might use one kind of support to establish a premise, while the larger argument uses a different kind of support. You honestly might switch back and forth from different kinds of support at different levels of the argument. What this means is that in the real world, argument structure can get really, really complex. And I know these diagrams, as they get complex, will be a pain in the neck to draw. But, well, I think it's good because it reveals what the structure of the argument actually is, right? And arguments can, in fact, have pretty complex structure. In fact, even really common arguments, arguments that are nothing special or exotic, that you'll see in the real world often have pretty complex structure when you break it down. And, if we're going to understand how these arguments work and whether they're good, we need to know what the structure is. So yes, it can be a chore, but it is worth it. Anyway, let me give you guys an example. And this is a pretty simple, well, not simple, but a pretty common argument, pretty commonplace, nothing weird, nothing exotic. It's just someone telling someone that they should take a class with a certain teacher. They should take calculus with this fictional professor, Dr. Jones, right? This guy I just made up. So the argument goes like this. If you want to learn calculus, you should take it with a good teacher. Because Bob wants to be an engineer, he needs to learn calculus really well. So he should take calculus with a good teacher. Dr. Jones has been teaching math for 30 years, and unlike some of the teachers here, he has a doctorate in his field. And everyone I've talked to says that while he may be a tough grader, he does an incredible job of teaching the subject. All that shows that Dr. Jones is a good teacher, so Bob should take calculus with Dr. Jones. All the premises laid out. There's 8 of them. Like I said, in the real world, things can get complicated, right? If you really want to learn calculus, you should take it with a good teacher. Bob wants to be an engineer, so Bob needs to learn calculus really well, so Bob should take it with a good teacher. Dr. Jones has been teaching math for 30 years. Dr. Jones has a doctorate in his field. Everyone I've talked to says he does an incredible job teaching the subject. Ergo, Dr. Jones is a good teacher. Remember I said ergo is kind of pompous, kind of pretentious, whatever, I'll just use it, right? It's another one of these terms that indicates a conclusion. Sounds a little fancy, right? Therefore, Bob should take calculus with Dr. Jones. So let's look and see how this argument's supposed to actually work, right? Like I said, 3 different levels. The first level here actually starts with premise 2. Premise 2 is supposed to support 3. He needs to learn calculus really well. That hooks up with premise 1. If you need to learn it really well, you should take it with a good teacher. That supports premise 4, which comes down here to premise 8. He's a good teacher and gets us 9, right? But look at what 5, 6, and 7 do. 5, 6, and 7, all the other reasons here are dependent support. 5, 6, and 7 all give independent support to this claim he's a good teacher, right? He's got a lot of experience, 5. He has a doctorate, 6. And everybody says he's really good, right? All of these are independent, and they support this premise 8 that hooks up with 4 to get you 9, right? Now look. Some of you at home are probably like hyperventilating and freaking out. Like, oh my God, is he going to expect us to do this? Yes, eventually I'll expect you to do this. Not this coming week, not for a while. I'm not going to make you guys do anything like this until we've had a lot of practice diagramming arguments, especially not on a test. We will practice, 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 practice before I expect y'all to do this.